ionic compound are sitting side by side. When an ionic compound begins to dissolve in water, the water molecule push themselves in between the ions of the compound and separate them from each other.
Thank you so much, Swasman. Wonderful reading. So people, so on dissolving in water. So what is dissociation? Okay, so it's a very big word, but don't be afraid. It's a very easy meaning. So disassociation. Okay, Isha raised the hand. I think you know what it means. So come off mute and share.
Separating the state.
Yeah, I couldn't hear you. Can you please repeat?
Disconnecting or separating the state.
Absolutely. So separation is nothing but dissociation. It's the completely opposite of, it is an antonym of what? Association, right? It's in the name. Okay. So disassociation of ionic compounds. So basically in the last lecture, we saw how ionic compounds are created by association, by exchanging transfer, business deals of electrons between each other. But now we are going to see how they are dissected, as Isha said, or they are separated. That's nothing but disassociation. It's the completely opposite of what association is. Okay. So basically, what it means is on dissolving in water. So, example, let's say I have a bottle or I have a beaker. Okay. So we are scientists right now. So let's say I have a beaker and I put water into it. Okay. Now I have water in it, and then I take some salt from my kitchen and I put it in the beaker. I mix it like rigorously and it dissolves completely. So what happens in such a case is that I have water and I have my salt, which is NaCl, which is basic salt. Everybody eats that. So such a compounds, so the compound is going to break now. So what happens is if you put water or if you put salt in water, sorry, the water molecules H2O, it goes between Na and Cl. Okay, so that's the easiest way to remember this. Let's say I have NaCl, which is nothing but sodium chloride, which is nothing but common salt. Okay, so now what I do is I put this, I have a beaker over here like this, and let's say I have water over here. So I have say water. So just assume this is water like this. It is like filled. Okay, and then what I do is I just put a pinch of salt, say, into the beaker. So now there will be a chemical reaction. Okay, and it's not out of this world. It's pretty basic. All of us do it. I've had lemonade or whatever. So this is what happens in this. So NaCl, what happens is when H2O and NaCl, they combine. What H2O does is like it creates a rift between Na and Cl. So it breaks this. So say the water comes in between them. So this is what happens. And due to this, we get Na plus and Cl minus. All right. So this is the basic premise of what dissociation is. I have water, I put a compound in it, and the water gets in between those two elements of the compound. So we have sodium as an element, we have chlorine as an element, and we have sodium chloride as the compound. What I do is I put into water, water comes between sodium and chlorine, and it breaks it apart. Okay, so this is basically what happens. This is basically what dissociation is. Water comes in between those compounds. And such a compound is known as aqueous solution. So aqua in Greek means water. Aqua, I think you might have heard about this. Aquaman, has anybody seen, Marvel movies? There is, DC movies, there is someone known as Aquaman. Jason Momoa played the character really well. So aqua means water, and man, you know what man means. So aqueous means a solution with water. Okay, that is nothing but aqueous solution means. Radha, you've raised your hand, go ahead.
Yes, bhaiya. Aqua can also be referred to aquatic plants like aquatic animals. So we get idea from this.
Absolutely. Aqua, this word is nothing but water in Greek. So what is aqueous solution? Any solution having water as the base. Okay. So I have a compound, any compound. Salt is just an example. I can put any compound in water. I just throw it in, and the solution I get is an aqueous solution. Why? Because it is mixed with water. So any compound mixed with water is an aqueous solution. Okay. So what does it say? In the solid state, the oppositely charged ions in the ionic compound are sitting side by side. So in the solid state, so let's say I have salt crystals, salt, basic salt. I take it from anywhere. I say salt crystals there. It's in the solid state, right? We have small, it's very small, but it's in solid state. We can handle it like this. And then I put it into water. What happens is that salt is nothing but an ionic compound. And what are oppositely charged ions is nothing but we have Na plus and Cl minus. Okay, so these are nothing but oppositely charged because plus is and minus is opposite, right? So when we put such a compound in water, what happens is that nothing but it begins to dissolve in water, obviously. And the water molecules, as I told you, H2O comes between Na and Cl. So if you look over here, so H2O, our water, comes in between these two oppositely charged elements or ions, not elements, ions. And the water molecules push themselves in between the ions of the compound and separate them. So nothing but Na and Cl, water gets into them, Na breaks off, Cl breaks off. Okay. So this is nothing but dissociation. And you can do it with any other compound as well, let's say HCl, hydrochloric acid. So I hope you might have heard about this somewhere, I don't know. We use it to clean toilets. So it's a really strong acid and its pH value is around 0.5, very strong. And you can't actually buy it in the store, like concentrated HCl. You can buy the diluted version to clean anything because acid kills germs and bacteria. Okay. A small little point is that if you use Coca-Cola, you can use Coca-Cola as a disinfectant. Disinfectant means you can put it in your toilet and clean your toilet with Coca-Cola. Okay, why? Because it is an acid. So anything which is an acid, especially a strong acid, can be used to kill germs. But it is very harmful to humans as well. So we'll cover that point later in uses of acids. Okay. So this is the basic point, folks, of what dissociation of ionic compounds is. And nothing but this is, I'm going to switch off my video because it's coming in between. Yeah. So this is how it looks. So this is a diagram I took from a textbook. So if you look over here, this is our beaker. We have our water over here and NaCl, salt, we put salt. And this water, this, the small brown thing you see over here, this is water, okay? Sorry, this is sodium and the green dot you see is NaCl. So what is happening in water is coming in between sodium chloride. It breaks apart, sorry, it breaks apart Na and Cl, okay? And this is what happens. So this is nothing but dissociation. We separate the oppositely charged ions with the help of water. And this is the complete chemical reaction. So folks, I'm going to request you to remember this. The chemical reaction is very important. Or just, instead of just rectifying it, what you can do is you can just understand what's happening and then you will get it. So let's say NaCl, S means solid. So over here, S means solid. This is what happens. We put it in water, dissociation happens, and we get Na plus AQ. AQ means aqueous, and Cl minus, again aqueous. Okay, so they no longer are solid, they are aqueous. Like it means that they are mixed in water. So for example, now let's say that I have a chemical reaction, something like this, HCl. Okay, this is an example. And in bracket, I write L. Okay, this is an L. So which state of matter is HCl in now, in this chemical reaction, like in this
Liquid.
annotation? Absolutely liquid, right? What if I write G over here, G, like this?
Gas.
So state of matter. Gas, yeah, exactly, gas. If I write S, then it is solid.
Solid.
Yeah, exactly. If I write AQ, then it is what? Obviously, aqueous. Aqueous means nothing but it is no longer in solid state. It is mixed with water. So you can always remember it like this, aqueous. Okay. So this is what the chemical reaction is. I'm going to request someone to just quickly take a screenshot of this, post it on the group and type a yes in the chat box because I can see your faces. Yeah, Radha, you raised your hand. Go ahead.
Bhaiya, but near the Na plus aqueous, so would it be same for all liquid, for all the states?
Like this, yeah. So, okay. So it is Na plus aqueous, is it because we have dissolved it in water? So if we haven't had, dissolved it in water, you would have had dissolved it in some else, some other base or some other solution. Then the annotation changes. It no longer becomes AQ, just becomes L, liquid, or G, gas, whatever, depending on the chemical reactions. So we'll see more about this in the next slides. Okay. Great. So Aditya posted it on the group. So thank you so much for it. All right. So we come to the second point of today, which is the Arrhenius theory of acids and bases. Okay. So what is Arrhenius theory of acids and bases is, So now Arrhenius is nothing but a scientist. It is a very smart guy. 19th century. This guy is a scientist and he's playing around. He's a chemist basically, and he's playing around with acids, bases. And just studying them. He wants to understand what is an acid, what is a base. Because folks, you have to remember that in the 19th century, we today have a lot of knowledge. Okay, we have a lot of knowledge about many things, but we have this knowledge is because many great people they worked on it. Okay, and they were very curious, very inquisitive. They always questioned why is it happening, why, how is it happening. Okay, and then they found the answer, and this is why we get the Arrhenius theory of acids and bases. So Arrhenius is nothing but a cool scientist. He proposed a theory of what acid is and what base is. Okay, so the next point is an acid. So he conducted many experiments and he saw that what can we define as an acid. Okay, and he got the answer. So I'm going to request someone who I haven't heard speak. So Aditi, if you are there, can you just quickly come off mute and read the definition of acid what Arrhenius gave us? Aditi, I'm not able to hear you. Folks, can you hear your friend? Because I can't.
No.
All right, no problem. Prince, if you're there, just quickly for us read the definition of acid on the screen.
An acid is a substance which on dissolving in water gives rise to H plus ion as the only cation.
Cation,
For
cation.
example, HCl, H2SO4, H2CO.
Thank you so much, Prince. So, folks, what Arrhenius saw in his experiments is nothing but he took acids, okay? He took substances and he found out that any compound, okay, if I put it in water and it gives me a H plus ion. So H is nothing but hydrogen plus. So if I get a positively charged ion of hydrogen, okay, then I will say that that compound is an acid. Okay, this is what Arrhenius meant. This is what his theory is actually. And then it works for any other acid. We have HCl, H2SO4, sulfuric acid, H2CO. Okay, so this is nothing but the basic Arrhenius theory of acids. So how does it work? You might be asking. So we get hydrogen H plus ion. Okay, so there is one more new word for you, I think so, is cation. Okay, this is not cation, it's cation. So what is a cation is nothing but a fancy word for saying a positively charged ion. Okay, positive charge, matlab H plus is nothing but a cation. Na plus is nothing but a cation, a positively charged ion. All right, and why is it called a cation? I'll tell you later on. Okay. Second is, just a minute, I'm seeing something in this. Oh, great, Rutu, you learned cation and I just wanted to cover it for you a bit because not to get confused. Okay. So cation is nothing but the positively charged ion which is attracted to the cathode. Cathode is negative. And anion is nothing but a negatively charged ion which is attracted to the anode, which is the positive part. In electrolysis of water, I think you may have studied this. If not, then we'll study it this year or next year. Okay. So yeah. So this is anion, a negatively charged ion, and it's great that you all know this. So I'm going to go ahead now. So on the screen, you're going to be seeing an image right now. There are 3 chemical reactions, and they're pretty basic reactions. I just took it from a textbook because it conveys the message that I want to teach you. Okay, so just hold on a sec. Yeah. So folks, now this is the image. The first is HCl. So I hope you all know how to read a chemical equation. Okay. If not, then tell me. Just put in the chat box yes or no if you know how to read a chemical reaction. Sorry, chemical equation, not reaction. All right. Okay, Aditya, you know. Okay, so great. All of you know. So first is HCl. Okay, I have hydrochloric acid. So HCl in the gaseous state, gas, it is G, gaseous state. We put it in water. Okay, so I put HCl in water. It is a catalyst. It's not catalyst, or and then dissociation happens. So this is the solution I'm putting it in. So this is water. This is the process which is happening, which is dissociation. What happens is that I get H plus cation, which is in aqueous state because it is being dissolved in water, plus Cl minus, which is the anion I get, which is in the aqueous state again. So this is nothing but a dissociation of acid in water. Now, the second and the third, I'm going to request, Aditya, can you just read the second equation for us? And the third equation, let's see who's the lucky one who's going to read this for us. Radha, okay? You can read the third equation for us, okay? So yeah, Aditya, go ahead. Aditya, are you there?
Yes, Bhaiya, what do I have to do? I couldn't hear.
Just read the second equation.
H2SO4 is in liquid form, and if we mix it with water, which is
Yeah.
then it disassociates, and
Yeah.
it becomes H plus, which is aqueous, plus HSO4, which is
Minus.
also aqueous.
Okay, thank you, Aditya. It's just aqueous, okay, not aqueous. So yeah, H2SO4 in liquid state, put it in water, dissociates to H plus cation aqueous plus HSO4 minus, which is anion aqueous. Okay, Radha, just quickly read the third equation, please.
Bhaiya, third is HSO4, anion 4 in aqueous state and is dissociation H cation in aqueous state plus SO4 to anion aqueous.
Yeah, so HSO4 minus aqueous solution. So this is nothing but a continuation of the second equation. So if you look over here, HSO4 minus, so it is over here. It dissociates to H plus aqueous plus SO4 2 minus aqueous state. Okay. So folks, this is nothing but now look, what we are reading over here is Arrhenius, what he said that if I put a compound in water and I get H plus ion, okay, H plus cation, H plus ion, positive over here. So I will say that this compound is nothing but an acid, okay? So if you look over these three chemical reactions, you can see that H plus aqueous, H plus aqueous, H plus aqueous. So now what will these three compounds be now? Okay, anyone? Will it be an acid? Will it be a base? Will it be a salt? What? Using the Arrhenius theory. Yeah, go ahead. Anyone, just quickly come up. Prathamesh, go ahead.
It's
Yeah.
acid.
Yeah, acid. Okay. Yeah, Radha, I think you also going to say acid. Okay. So yeah, folks, now this is the basic part. Okay. Drill it in your mind that if I have a compound put in water, H plus means, if I get H plus ion, it is an acid. Okay. So this is the Arrhenius theory of acid. Now we'll say base. What is Arrhenius theory of base? So if you understood this, give me a yes in the chat box. How can we identify between an acid and a base? Arrhenius theory. So if you understood, give me yes. So I can see what Aditya, Radha, rest of you, man, are you even there? So Pratham is also giving me a yes. I'm gonna wait for like 4-5 more people so that I understand. The point has been, going across. So as a Sandesh Kimya, Aditya, Sakshi, Bhumika. Oh, great. Thank you so much. So folks, this is the Arrhenius theory of acid. So we'll go ahead and see what is the Arrhenius theory of base now. All right. So I'm gonna request someone who I haven't heard, somebody lovely voice. Let's say Jatin, if you're there, just can you read what's written on the screen?
Base.
Yeah, read the complete definition of, yeah.
Substance which on dissolving in water gives rise to HO plus HO ion as the only action. For example, NaOH and Ca bracket OH2.
Okay, so thank you for that, Jatin. Good try. So basically, folks, now Arrhenius theory of acid said that compound, if it dissolves in water, get H plus, then it is acid. So for base, it's just that a base is a substance which on dissolving in water gives us the OH minus ion, OH minus hydroxide, okay, OH minus ion, as the only anion. For example, NaOH, sodium hydroxide, or CaOH twice, calcium hydroxide. Okay, CaOH twice. It is read as CaOH twice. Okay, this is how you read it. So wait a minute, I'm just gonna give you one more example. Let's say we have something like this. How do we say it? Just anybody just quickly come off mute and tell me how do you say this? Yeah, anyone?
Oh, what is this? 2 और ये 4 है ना?
So Na2SO4.
हाँ.
Yeah. I'm gonna give you one more example. Pratham, you just stay with me. I have something
Okay,
known
okay.
as, let's say, there's a 2 over here and 3 over here. How would you say this now?
If there is 2 तो twice बोलते हैं ना?
नहीं. Only if there is a bracket, you say thrice, twice. Okay. Bracket नहीं हो तो you only say 2 or 3. So how would you say this now?
Ca2OH thrice.
Exactly. Great. Okay. So CaOH twice and NaOH. So basically, Arrhenius says that if I have a base, if I have a compound, this is my compound like this. This is a beaker. This is water. I put this compound in this beaker, and if I zoom into this, I see that I am getting OH minus ions. Okay, negatively charged ion, which is known as anion. Then I'll say that it is a base. If it would have been H plus, I would have said it is an acid. Okay. So I'm going to show you on the screen some two equations so that everything gets cleared. So the first is NaOH solid state. So sodium hydroxide in the solid state, put it in water, it dissociates, and then we get Na plus aqueous plus OH minus aqueous. Okay, so we get sodium cation and hydroxide anion. So the next is, okay, I'm going to request someone to read this. The next one, let's say who is, in our class. Payal, if you're there, just can you read the second equation for us? Yeah, Payal, go ahead. I think, Payal, I'm not able to hear you. Folks, can you hear Payal? Because she's not audible to me right now.
No.
No.
Okay, no problem. Let's say, Sandesh, if you're there, just can you quickly read the equation on the screen, second one? Yeah, go ahead. Or even I even can not hear Sandesh. Okay, let's say, Dheeraj, you had raised your hand, I saw. So if you want to go and read this, go ahead. Folks, we need more energy in this classroom. What is happening? Anyone just come off mute and read the second equation. If you have a problem anywhere, just tell me ki, "Bhaiya, I can't solve." I'll help you, obviously. Pratham, go ahead.
हाँ. CaOH twice.
Yeah.
Solid
Yeah.
state. When mixed with water,
Yes.
dissociation, and then gives out Ca2 cation.
No, just say Ca2 plus.
अच्छा हाँ ठीक है. Ca2 plus aqueous plus 2OH minus aqueous.
Absolutely. Thank you so much, Prathamesh. So yeah, CaOH twice solid in water dissociates to give us Ca2 plus aqueous, which is a cation, plus 2OH minus aqueous, which is an anion. Okay. So folks, this is nothing but the Arrhenius theory of base. He saw that if I have a compound, put it in water, and I see that I am getting the OH minus anion on dissociation, then I'll say that it is a base. All right. So this is nothing but the basic Arrhenius theory of acids and bases. If you have understood, the acid-base part, just give me a yes in the chat box. If no, then come off mute and ask me, go ahead and ask your queries. Always. That's what I am here for. Okay, Radha, Kimaya, Aditya, Pratham, Ritu, Sandesh, Sujal. Okay, great. And see yeses from most of you. If you have not understood, always please come off mute, ask. There are no silly questions, okay? The faster you get your queries cleared, it is better, because I am a firm believer in, imparting knowledge. So it doesn't matter if you think that your question is silly, it is not. And it's better to have your doubts and your queries cleared beforehand rather than having a confusion in your life. Okay, great. So we go to the now third part of our day, which is nothing but acids. So finally, folks, we come back to acids after such a long thing. Okay, so many before things you have to do, but this is science. We can't help it, right? And yeah, so the definition of an acid is nothing but, as Arrhenius the Great told us, is that an acid is a substance which produces hydrogen ions, H plus aqueous, in water. So you can see a basic diagram over here, what Arrhenius was saying, what he meant. So we have an acid over here, just plop it into water like this in beaker. What happens is that it dissociates, gives us H plus. Okay. Pratham raising a hand, go ahead.
If the H plus ion is not aqueous, then is it acid?
Yeah. So it is not an acid. Okay. So first of all, Pratham, whenever you put it in water, it is going to be aqueous. Like that is the rule. So Arrhenius' theory, it only holds for compounds put in water. Okay. It doesn't hold for compounds put in other liquids. Always remember this. It's only for in water. Okay. So it's all, the H plus is always going to be aqueous. I hope you are I've cleared your query. So
Yes.
So cool. So there's one more example over here. So we have hydrochloric acid. It's like one of the most famous acids ever to exist. HCl. Okay. There's another company in HCl, but anyway. So hydrochloric acid dissolves in water to form hydrogen ions over here and chloride ions over here. So this is nothing but the chemical reaction. HCl aqueous in water dissociates to give us H plus aqueous cation plus Cl minus aqueous anion. Okay. It is the hydrogen ions which turn blue litmus to red and give acids their characteristic properties. Okay. So can anyone, have you ever heard about what a litmus is? Litmus. Okay, if you have heard about it.
Yes, bhaiya. Litmus paper.
Exactly. So where is it used?
भैया वो कुछ तो एसिड में डाला ना तो वो ब्लू क्या ऐसा हो जाता है रेड या ब्लू.
Absolutely, yeah. So basically what it means is it is a test. We literally have a piece of paper and you just put it, in your acid or base or whatever solution you have. So if it's a blue litmus paper and it turns red in color, blue to red, okay, always remember it, like in the back of your head, blue to red. So blue to red, then you say that it is an acid, okay. Now if I have a red litmus paper, I put it in the solution and it turns blue. So then what is the solution then? Exactly ulta. Red to blue. Yes.
Basic.
Absolutely, yeah. Basic, right? So blue to red is acidic, red to blue is basic. And that's it, like basically. And basically the H plus, the H plus ion is the one which gives the properties. So characteristic properties of acid. So it is H plus hydrogen ka cation which dictates how an acid is going to behave. Okay. And now this is actually pretty in detail. You don't have this for 9th standard, but one day I hope you will, learn about this later on. Great. So Pratham, a great question. What if red litmus is used to check acid? So can anyone tell me the answer for this? Just think for a second.
भैया अगर हम अपोजिट करें लाइक यहाँ पे कैसे क्या है ब्लू टू रेड हो रहा है तो रेड टू ब्लू हो जाएगा ना ऐसे.
Yeah, so rather just
I think the color won't change because red shows only acid and blue shows only base. So the color will not change.
Absolutely, Aditya, absolutely. Sujal, you have raised your hand. Sandesh raised your hand. I didn't see that. So if you have anything to share, if you have the same answer. So yeah, folks, if the red litmus is red, and if I put it in acid, it's going to turn red. So red on red doesn't show. Okay. So Pratham, it's not going to change. The color won't change. Similarly, if I take a blue litmus and put it in a base, the color is not going to change. Basically, blue and blue, you won't see the difference basically. Okay. So yeah. So this is the thing. This is the definition of acid. So basically, I'm going to request someone to quickly take a screenshot, post it on the group so that we can move ahead with our day. And give me a yes in the chat box so that I know because I can't see you right now. All right, I'm waiting 5 seconds, folks. Quickly do that. Okay, Isha, thank you so much. So, folks, we go to the next part. What are acids? You know, we just saw what an acid is: H plus ions, compound with H plus ions, which dissolves in water. Okay. So now these are the basic little properties of acids, which we will cover in detail later on. Okay. So the first is that acids react with metals to produce hydrogen gas. So if I have a metal, okay, so in this over here, I have magnesium as the metal. Magnesium plus sulfuric acid gives me NgSO4 plus hydrogen. Okay, now this is hydrogen gas. And it is a test actually. So if you want to test, whether the acid is an acid or not, you can just quickly put metal into it and you will get, NgSO4 plus H2. I really hope for this lesson we would have been in the lab, the science lab. It would have been amazing because when you put
Ray, in our home, we don't have base, but I have acid, and I don't do any experiment because if the acid smells very bad, like if we
Exactly,
open it,
Adi, good point. That's something I forgot to tell you, folks. If you will have acid in your homes to clean your toilets or whatever, please don't play with it. Please, like you may be learning about reactions right now. Please don't go home like you are at home and say to your mom that abhi acid lekya tha, I'll just experiment. Please don't do that. It's very risky and it can burn you, like literally first degree burns. So please don't do that. Okay. Great. Sujal, you're raising your hand. Go ahead.
But bhaiya, we also have natural acid that have in vegetable like lemon have citric acid. Then we do experiment with this.
Absolutely, Sujal. Again, very nice point. So yeah, folks, whatever acids you find naturally, which you eat, okay, like citric acid, as Sujal said, they're edible. So yeah, you can do experiments with that. A basic experiment which you can do is that you can take lime water, okay, CaCO3, and you can put it on a earbud or something, write something, and then it won't show naturally. But if you put UV light on it, then you can see that message written using lime water. So this is some little experiment you can do. It is known as invisible ink. So invisible ink is made by that. Okay. So yeah, citric acid. There is one more, vinegar. I think you may have heard about it. Acetic acid, like vinegar. Your mom might be using it in cooking. CH3COOH. So that is some acid we use in our lives. So wait. So folks, now this is hydrogen. And best part about this is why I told you that I wanted to be in the science lab for this is because if you mix magnesium with sulfuric acid, there's a pop. Like you can literally hear a sound. It's a pop hota hai. You can see it in this photo here. So yeah, you can hear a pop and it's really amazing. So now acids react with carbonates to produce carbon dioxide. So CaCO3 plus 2HCl produces CaCl2, calcium chloride plus water plus CO2. This is carbon dioxide. Calcium carbonate plus 2HCl, hydrochloric acid. So all of these tests, folks, I guess like once school starts, I'm going to show you even if we are done with this chapter because this is really interesting. Like to see this happen in real life, it is something else. And I really hope that we are able to do this. Okay, because science is something you don't learn on the screen, you learn by doing it, right? So yeah. So these are the basic chemical reactions you can see using acid. So other chemical properties are nothing but acids react with bases to form salt and water. Okay, so now this point you have to always remember for the rest of your life. So anyone who wants to study chemistry or become an engineer, very important. Acids react with bases to form a salt and water only. Okay, this is known as neutralization. So can anyone tell me why is this process known as neutralization? I have an acid, I mix it with a base, okay? I get a salt plus water. So why is it called neutralization? Can anyone tell me? There's a hint in the name itself. So let's say we can see Pratham. Pratham, go ahead.
Yes, this is called neutralization because if acid is means if acid is more or base is more, so to means control the effect of both of these and to make it unharming means it won't harm, so we do neutralization in which we add acid and base to get salt plus water.
Absolutely, yeah, that's a good point. If you want to reduce the harmful effects of acids, then we put a base in it. Okay. Sujal, you're raising your hand. Go ahead if you want to share.
Yes, bhaiya, acid and base get equal, then we get both are equal, and we get salt. Therefore, I think so. This process is called neutralization.
Absolutely, yeah. Great. So it is called neutralization because there is the word neutral in it. Neutral. Neutral means what? So you can think about acid as yin or 1 point. Like let's say acid, and acid is the villain and base is the hero or something like that. That's just an analogy. It's nothing like that. So acid and base, they cancel out each other. Okay. And then you get nothing but something which is neutral. So all salts are neutral. Okay. Salt and water, which is neutral. So that is why it is called as neutralization. And always remember, folks, now this is the basic definition. It also depends on the pH value. pH means potens hydrogen. And this is a different concept. I don't know if you have heard about it, pH. So the pH of the acid is 0.1. Water pH level is nothing but 7, which is the basic pH level. Then base NaOH concentrated has the pH level around 13 or something like that. So this is a different concept, but don't worry, I'll teach you later on about that. So always just keep it in mind, and neutralization has the word neutral in it. Neutral means nothing but cancelling out each other. So as Sujal said, acid and base, they react with each other to form salt and water. And as Pratham also shared that these reactions are used sometimes to protect other people from the harmful effects of acids. Sometimes in the rivers or in the streams, acids or bases, they just get flowed. So to minimize the effect, we put the antigen. We call it antigen. Okay. Anyway, second point is sulfuric acids react. So this is a chemical reaction of neutralization, which you can see. So sulfuric acid, H2SO4, reacts with copper 2 oxide. So this is CuO, copper oxide, to form a salt called copper sulfate. Okay, and water. So copper sulfate is nothing but a salt. The most common salt you all know is nothing but NaCl, which is salt. It is known as common salt. So copper sulfate is also salt. There are many salts in the world, plus H2O, which is nothing but water. So this is a basic neutralization reaction you can see over here. Pratham, yeah, go ahead.
Question.
Yeah.
Sometimes when in the atmosphere, when the acid increases, then all the acidic gas falls as acid rain. So what if somehow we also create a cloud which has base in it, and when it falls together, will it be salty water rain?
In theory, it should happen, but practically it won't, because you can't create a cloud with base in it. And the reason for it is what I'm going to do is you can search for it actually. Okay. And technically it should be possible, but in real world, reality, it can't be done. Okay. So if that would have been the case, the acid rain wouldn't have happened, right? And acid rain, why does it happen? Can anyone tell me? Like, what is the reason behind acid rain? Like, what happens exactly? Yeah. If no, then yeah, it just different, different information for you. So nothing but nitrogen oxides, sulfur oxides, carbon oxides, they mix with water and they form nothing but acid. And then it gets into like the water cycle. All of you know the water cycle. So that's how the rain gets perpetuated everywhere. All right. So this reaction is neutralization. So I'm just going to quickly clear my screen, and someone just take a screenshot of this neutralization reaction. The concept is pretty easy. If you have focused on the lecture today, folks, you would have understood that this lesson is not difficult. It's just that there are many chemical equations that you have to remember. Okay. And my suggestion to you is that don't just remember them, understand them. So once you understand them, then it's pretty easy to remember. Okay. Great. Thank you, Radha and Isha. You both have put it. So thank you so much. So come to the next point is this: what is strong acid and a weak acid? Okay. And then we come to the some common acids. So strong acid and weak acid. So what is a strong acid? Is nothing but a strong acid, an acid that is completely ionized in water. So completely ionized means if I have a compound, okay, and I throw it in water or put it in water to be more civilized, put it in water, and all the hydrogen ions, they dissociate all in the compound 100%, like not 190 to 100% of the hydrogen atoms, ions, sorry, they separate. If this is happening, then I'll say that it is a strong acid. Okay. Example of strong acids are sulfuric acid, hydrochloric acid, nitric acid. And similarly, a weak acid is nothing but an acid in which the hydrogen ion does not get completely ionized, it does not get completely dissociated. So if I have a compound, only 40% of it will get dissociated. The rest 60% will, just float, just be in that solution. Okay, that compound will not dissociate, it will dissolve. So folks, okay, now there are two different words I used. So what is the difference between dissociation and dissolving? Can anyone tell me? Dissociation and dissolving. It's very important for you to know. So dissolving is nothing but that a compound gets mixed with water. Dissociate means that the compound gets ionized, means uska ions टूट जाता है. Dissolving means the entire compound gets mixed. Okay. And always in dissolving there is some kind of dissociation, but that's later on, not now. 11th standard में पढ़ लोगे तुम. So yeah. So strong acid is nothing but, let's say, I'm gonna just draw on the screen so that everybody can understand what is happening. So yeah. Let's say over here I have a compound like this. I throw it in water. So हमारा water इधर है like this. Okay. So now what is happening in water if you look? वो जो compound है उसका only 40% of H plus ions they came out. They were separated. Rest 60% is nothing but the original compound itself. It got dissolved. So this will be a weak acid. But if I throw this same different compound and 90% of H plus ions get separated and only 10% dissolves, I'll call it a strong acid. Okay. So now if you have any questions about this, quickly come off mute, ask me. If no, put a yes in the chat box. So then we'll move ahead. Yeah, so let's say I'm seeing some activity in the chat box. So I'm just hold on a sec.
भैया
Yeah.
ये जो अभी आपने जो ड्रॉ करके बताया था ना वो will you explain it again?
Just a minute, Pratham, ask me in English again, please. Sorry to be a jerk, but I want you all to speak only in English. So, it's your practice. Yeah. So sorry to do this, man. But yeah. Hello. Yeah. Ask.
Okay. Will you please explain it again? That
No
you drew
problem.
it here and
Yeah,
Ah.
no problem. Okay. So, okay, folks. Just also one thing. Whenever you speak to me, please speak in English because you might think, ki, Bhaiya, what Bhaiya is doing, such a Hitler, attitude Bhaiya has, and he's troubling us. Yeah, I'm troubling you, to be honest. But it's just for your own good because 10 years down the line, you will be fluent in English. Forget 10 years, 4 years down the line when you will be in college. And if you are proficient in English, it will be better for you. It's actually pretty, it's a different topic, but yeah, that's going to increase your popularity in college. And that's the sad truth of India. So yeah, focus on English, folks. Okay, great. So I have a compound like this. Okay, Pratham. So this is a compound, let's say compound. And over here, I have a beaker, which has water in it. Okay. So now this is a beaker, there's water. What I do is I put this compound in water. So now what is supposed to happen is, let's say it is HCl. Okay, I'm just giving an example. Okay, people, HCl is a very strong acid. But if I put this in water, what is going to happen is nothing but H plus ions and Cl minus ions are going to dissociate. Okay. Now, if this dissociation is around 90 to 100%, then I'll say it is a strong acid. But if only 40% gets dissociated and the rest of the HCl is just, say bottom pe reh jata hai, it only dissolves in water, it doesn't dissociate, then I'll say it is a weak acid. Because if you think about it, the number of H plus ions, they dictate how strong the acid is. If only few H plus ions get dissociated, then it will be weaker. If more H plus ions get dissociated, it will be stronger. Okay. So the number of dissociation happening in that water is known as weak or solid acid. And there's a word for it. It is known as ionization. Ionization is nothing but breaking of the ionic compound. So when the ionic compound breaks into its positive and negative ions, that process is known as ionization. So from this, we decide if it's a weak acid or a strong acid. All right. Prathan, have you understood this? If not, then I can re-explain. All right, great. So, folks, these are some common acids, sulfuric acid, hydrochloric acid, nitric acid, citric acid, ethanoic acid, also known as acetic acid, which is vinegar. So, hydrochloric, you have at home to clean your toilets. Nitric acid, you may find, where do you find nitric acid? In your body, actually, you might find nitric acid. Citric acid is C6H8O7, which is nothing but in lemon, lemonade, sweet lime, you get citric acid. Citrus fruits, basically, citrus fruits. Ethanoic acid is vinegar, which your mom might be using or dad might be using, whoever cooks in your family, I don't know. CH3COH, in the kitchen or whatever. So yeah, folks, these are the basic acids now. Now we come to the last slide of today, last part, ekdam end ho gaya abhi lecture. Okay, just bear with me for like 7 to 8 minutes now. So yeah, if you have understood till here, folks, just give me yes. If not, then keep that query with you. After the lecture, you can ask me, okay? We're a little short on time right now. So we come to the last part of today, folks, which is nothing but base. Okay, so we learned about acids, learned a lot about acids. So what is a base? So what Arrhenius told us is a base is an oxide or a hydroxide of a metal. So nothing but MgOH twice. So in this, we have the hydroxide, which is the OH, and Mg is nothing but a metal. If you see NaOH, OH is the hydroxide, Na is what? The sodium. Sodium is a metal. Okay. So the many examples are nothing but sodium oxide, sodium hydroxide, copper oxide. And here again, neutralization is seen. Same concept. So folks, as I have said about acid we have H plus, base we have OH minus. All right. So this is the basic difference between them. How to know if it is an acid or a base? Just use a litmus paper. If you don't have a litmus paper and if you really want to go into the depth of it, just put it in water, check for H plus, OH minus ions, whichever is more, it will define if it's a base or an acid. Okay. Great. Isha raised her hand. Go ahead. Isha, your question, was it a mistake? I don't know. Yeah. So people, okay, no problem. So I'm going to pose a question. So we know what a weak acid and a weak acid and a strong acid is. If you use the same concept, can anyone tell me what a strong base and a weak base and a strong base could be? Using the same concept of strong and weak acid. Pratham, go ahead.
A strong base would be when dissociated or when mixed in water. A strong base would dissociate 90 to 100% and would release more OH minus ions, and a weak base won't dissociate, means will dissociate 40% and will release less OH minus ions.
Exactly. Bang on, Prathamesh. It's just that the percentages I told you, they change for different acids. Okay, so 90, 100 is a stipulated name. So they change for different acids, but the basic point is that if more ions are getting dissociated, then it is strong. If less ions are getting dissociated, it is weak. irrespective of it is hydroxide or it is H plus. Okay, so the basic thing. So if you understood this, give me a thumbs up, not thumbs up, give me a yes in the chat box because we don't have the liberty of seeing you. Rather, you raised a hand, go ahead.
No, bhaiya, by mistake.
Acha, no problem. All right. Yeah, so I'm seeing a couple of yes in the chat box. So folks, I'm gonna go ahead to the check. So this is the last slide for today. And okay, the first question I'm gonna request now, I'm gonna cold call, not the usual people. Let's say Sakshi, if you're there with us, can you come off mute? Read the first question and answer the first question.
The process of forming of salt and water of the mixing of acid and base is known as neutralization.
Absolutely, Sakshi. Kudos to you. It is neutralization. Okay, great. Now the second question we'll talk about. Let's say, who do I choose? Bhumika, if you're there, can you just answer the second question for us? Read the question and then answer. Yeah, Bhumika, are you there? All right. Okay. I'm seeing one answer. Kimaya, you have sent me H minus, so I'm gonna just change it a little bit. Folks, what ions do acids produce in water? It is H plus. Exactly, H plus. Always remember. Third question. Who do I ask? Let's say Kimaya, if you're there, can you just quickly come off mute and read the third question and answer it for us? Come on, folks. Only 2 questions to go for the lecture to end. All right, I see that people are not here. Okay, no problem. So let's say Sujal, go ahead and answer this question.
What is the difference between a strong acid and weak acid? Bhaiya, strong acid are very harmful because they harm to us, and weak acid are not very harmful. They are natural. That is the difference in strong acid and weak acid.
Sujal, yeah. So your point is correct. What I'm asking you is, can you tell me it in a scientific way? How as a scientist would you define them? Strong acid and a weak acid. That's what I'm asking for. Okay, I'm seeing Suhas raising a hand. I'm seeing many people, but I'm going to give a chance to Suhas. So Suhas, question 3. What is your answer for it?
Strong acid dissociate fully in water, and weak acid do not fully dissociate.
Yeah, so strong acid completely or almost completely dissociate in water, forming H plus ions. Weak acid do not dissociate in water completely, so they are known as weak acids. Other difference is, folks, that the process is known as ionization. So breaking of ionic compounds, forming an ionic compound is known as ionization. So people, we come to the last question of today. Pratham, you're saying they give more ions, which is absolutely correct. The last question is, what does the Arrhenius theory of acids and bases say? So what I'm trying to ask you is, how has it defined an acid and how has it defined a base? Can anyone quickly, in your own words, tell me? Let's say, Isha, go ahead. Because folks, Aditya, Pratham, rather, you have shared a lot, so I really appreciate it, but I'm going to give a chance to someone else, okay? Isha, go ahead. Answer the fourth question.
So acid is a substance which dissolve in a water and rise H plus ion, and base is a substance which dissolves and rise up OH minus ion.
Thank you so much. Absolutely correct, Isha. Okay. So acid give H plus, base get OH minus. That's it. That's the Arrhenius theory. So folks, with that, we come to the end of the lecture today. Kudos to you all. You are amazing. So I'm going to stop